Hi, I'm Dimitris Charalambidis, and in this presentation, we'll work together an exercise that is similar to a past paper exercise. So here it is. A gradient function is given by dy over dx equals x squared plus 5x. When x equals 0, y equals 3. Find f of x and then calculate f of 2. We'll begin by noting that dy over dx is actually a different notation for f prime of x, and thus we are given that f prime of x of a function f is equal to x squared plus 5x. Now we know that in general a function f of x is equal to the integral of f prime of x dx, which in our case is translated to the integral of x squared plus 5x dx, and all we have to do is actually find this integral. The first thing we do is split it, since it's a sum, so we should split it into two integrals, one for each of its terms. So we would write integral of x squared dx plus integral of 5x dx. Integral of x squared dx is equal to x cubed over 3, while integral of 5x dx can be written as 5 times integral of x dx, which of course is equal to 5 times x squared plus 2. And since it's an undefined integral, we should not forget about the constant value c we put at the end. So finally, f of x will be written in a form x cubed thirds plus 5 times x squared over 2 plus c. To find c, we must use the given boundary condition. We were told that when x equals 0, y is equal to 3. This translates in the expression f of 0 equals 3. F of 0, considering the form for the f of x we previously found, will be equal to 0 cubed thirds plus 5 times 0 squared over 2 plus c, and all that must equal 3. Thus, c will be equal to 3. Finally, our answer will be that f of x is equal to x cubed thirds plus 5x squared over 2 plus 3. For any questions about this presentation, you can leave comments down below, or you can contact me with one of the following ways, either on my email or at my Facebook page. As always, thank you for your time.